The original price of this car is £8,999. What is the sale price of the car? So we can see that in the sale we get £1,100 off. So that means it will be £1,100 cheaper than £8,999. So that's £7,899 because we just need to subtract 1 from the thousands and 1 from the hundreds. Or we could use column subtraction and we get the same answer. We have the number 3,576,219. Which digit is in the 10,000s place? So with whole numbers, we count place value from the right. So we have our ones, tens, hundreds, then our thousands and 10,000s. So the digit in the 10,000s place is a 7. And it's important that we write the digit. So write 7, not 70,000. 70,000 is the value of the digit, but the digit itself is just 7. Now round 3,576,219 to the nearest million. So we can find the millions digit, which is the first digit in a 7-digit number, or the digit that comes before the first comma. So we find our millions digit, and then to decide whether we need to round up or down, we look at the digit to the right. Now we have a 5, and we know that if we have 5 or more, we need to round up. So that means the digit we've circled increases by 1, so the 3 becomes a 4, and then digits to the right turn into zeros, so that's 4 million. Dev says, I had £10, I gave some money away. Which expression shows how much money Dev has left? A is the amount of money in pounds that Dev gave away. So if he gave away money, that means he lost money. So we need to subtract what he gave away from what he started with. So here we need to tick the expression 10 minus A. And then we can check that it works, because if, say, Dev gave away £1 and he had £10, that means he would have £9 left. And 10 minus 1 is 9, so we know that the expression will be 10 minus A. So what he started with minus what he gave away will tell us how much money he has left. Write these masses in order, starting with the lightest. So we have 1.25 kilograms, 0.99 kilograms, 1.025 kilograms, and 0.009 kilograms. So I've written the numbers out one below the other with the decimal points lined up, because if the decimal points are lined up, then the place values, so the ones, tenths, hundredths, and thousandths will be lined up as well. Now what we can do is write zeros in empty squares so that our numbers all have the same number of decimal places. So here they all have 3 digits after the decimal point. And that means we can compare these numbers in the same way as if we were comparing whole numbers. So starting with the place value on the left. So our ones digits are 1, 0, 1, 0. So one of the numbers with 0 in the ones will be the lightest. But if we look at our tenths digit, here we have 9 and here we have 0. So that means this number here with a 0 in the ones and the tenths will be our lightest mass, and then we have 0.99. Then both of our remaining numbers have 1 in the ones, but if we look to the tenths, here we have 2, but here we have 0. So that means 1.025 will be next, and then our largest mass is 1.25. because that has a 1 in the ones, but it has a 2 in the tenths, and this number has a 0 as the tenths digit. Now the other thing that you can do to save you some time is just write the numbers out with zeros in the question that they've given us. So 1.25 is the same as 1.250 and 0.99 the same as 0.990. And our other numbers have 3 decimal places, 3 digits after the decimal point. So now, because we've put zeros on the end, all of our numbers have the same number of digits after the decimal point, so we can compare them in the same way as if we had whole numbers. So as if we had 1,250, 990, 1,025 and 9. Write the missing digits to make this addition correct. So what I would suggest you do here is write the question out as a column addition, because then we can find the missing digits by following the same steps that we use for column addition. So that's starting with our ones column and working to the left. So in our ones, we have something plus 2, and we have a 0 as the ones digit of our answer. But clearly they haven't added 2 to make 0. They must have added to make 10 and then carried the 1. And 8 plus 2 is 10, because 10 minus 2 is 8. So this digit here must be 8. Then we have onto our tens 1 plus 2 plus something, and we have another 0. So again, they haven't added to make 0, they must have added to make 10. So 1 plus 2 is 3, and 3 plus 7 is 10, because 10 minus 3 is 7. And then onto our hundreds, we have 1 plus something is 2, so this missing digit here must be a 1. So that means we have 128 plus 72. John buys 1 toy car and 1 pack of stickers. He pays with a £10 note. How much change does John get? Well, first, let's work out the total cost of a toy car, so that's £1.49, and a pack of stickers, so £1.64. That comes to £3.13. So that's how much the car and the stickers cost. So what we can do is subtract that total from £10, and that will give us the amount of change. So we need to subtract £3.13 from £10. But remember, £10 can be written 10.00. So then we can do the column subtraction with lots of exchanging, and that gives us £6.87. So that's how much change he gets. This picture shows the masses of 8 kittens. What is the difference in mass between the heaviest kitten and the lightest kitten? So the heaviest will be the kitten which weighs the most, so we need to find the largest number. And that's 410, because we have a 4 in the hundreds, and all of our other numbers have either a 2 or a 3 as the hundreds digit. And then the lightest kitten is 255 grams. So we need to know what is the difference, and we find the difference using subtraction. So 410 minus 255 is 155. So 155 grams is the difference. Now, the masses of the kittens are to be put in 4 groups. Write the missing numbers in the table. One has been done for you. So first we need to know the number of kittens that are between 250 and 299 grams. So that's 255 and 275. So that's 2 kittens, because all of our other numbers either have a 3 or 4 as the hundreds digit. And it's a good idea to cross them off as we count. So now we need the mass between 300 and 345. So that's 305, 310 and 345. So that's 3 kittens, and again we can cross them off once we've counted them. Then from 350 to 399 we have 375 and 360. So that's 2 kittens, and then we just have 1 kitten left, which weighs 410 grams. So that's 1 kitten that's between 400 and 449. Ken is playing a game. He has 4,289 points. Then he scores another 355 points. Ken's target is 6,000 points. How many more points does Ken need to reach his target? So first we can find how many points he has by adding the points that he started with and then the extra points that he scored. And 4,289 plus 355 is 4,644. So that's how many points he has, but we're asked how many more points does he need to reach his target of 6,000 points. So we need to find the difference between what he has and 6,000. So we can subtract 4,644 from 6,000. So here for this column subtraction we need to do a lot of exchanging, but then we get 1,356. So that's how many more points Ken needs. This pictogram shows the number of satellites above the Earth in 2016. How many satellites were above the Earth in 2016? Well, from the key on the pictogram, we can see that one circle is 1,000 satellites. So we have 1,000, 2,000, and then we have a quarter of another circle. So we need to find a quarter of 1,000, and to do that, we can divide 1,000 by 4, and that gives us 250. So altogether, we have 2,250 satellites above the Earth. On the grid, there are 3 points joined by 2 lines. Lara plots another point on the grid at -1, 2. She joins the points to make a quadrilateral. Complete Lara's quadrilateral on the grid. Use a ruler. So the coordinates are -1, 2, and we need to remember that the x coordinate is written first. So the x-axis is this line here. So we know that the coordinate of the point has to be in line with -1, and then we have a y-coordinate of 2, so we need to plot our point here, because when we go down to the x-axis we have -1, and when we go across to the y-axis we have 2. So we can join the points to complete the quadrilateral. Then Lara translates the quadrilateral 4 squares to the right. Draw the quadrilateral in its new position on the grid. So translates just means moved, so we need to move this quadrilateral 4 squares to the right. So if we take this point here, we can move that 1, 2, 3, 4 squares to the right, and then we can see that we have a line of 2 squares. Then to get to this point, we go up and across by 1. To get to this point here, we could go down 5 and across 1, or we could just count 4 to the right from this point. So that's 1, 2, 3, 4, and then we can join up our points, and we've translated the quadrilateral. Here are 5 numbers, so we have the numbers 2 to 6. Write each number on the correct cards. The number 2 has been written on the correct cards for you. So first, for this card, we need to see if the number is a prime number. And remember, a prime number is a number with only 2 factors. it's only in the 1 times table and its own times table. So 2 is a prime number because that's only in the 1 times table and the 2 times table, not in any other times tables. And then we need to see if the number is a factor of 12. So remember, a factor of 12 will be a number that has 12 in its times tables. So factors are the opposite of multiples. And 2 is a factor of 12 because 12 is in the 2 times table. Or another way of thinking about it, we can divide 12 by 2 and we get 6, so we get a number that does not have a remainder. But 2 is not a factor of 15 because 15 is not in the 2 times table. So now let's take the number 3. That's a prime number because 3 is only in the 1 times table and the 3 times table, not in any other times table, so it only has 2 factors, which means it's a prime number. And 3 is a factor of 12 because 4 times 3 is 12, so 12 is in the 3 times table. And 3 is also a factor of 15 because 5 times 3 is 15, so 15 is in the 3 times table, which means that 3 is a factor of 15. Now the number 4 is not a prime number. The factors of 4 are not just 1 and 4, but also 2, because 2 times 2 is 4. So because the factors of 4 are 1, 2 and 4, it has 3 factors and a prime number only has 2 factors. Now 4 is a factor of 12 because 12 is in the 4 times table. 3 times 4 is 12. But 4 is not a factor of 15 because 15 is not in the 4 times table. If we divide 15 by 4, we'll get a remainder. So now let's look at the number 5. That's a prime number because it's only in the 1 and 5 times table. It's not a factor of 12 because 12 is not in the 5 times table. But 15 is in the 5 times table, so 5 is a factor of 15. Now 6 is not a prime number because the factors of 6 we can make 6 not just with 1 times 6, but also with 2 times 3. So 2 and 3 are factors of 6 as well, so it's not a prime number. It is a factor of 12 because 12 is in the 6 times table, but it's not a factor of 15 because 15 is not in the 6 times table. Amina's bed is 190 centimeters in length and 91 centimeters in width. She is making a 1/10 scale model of the bed. What are the length and width of Amina's model? So it's a 1/10 scale model, so we need to find 1/10 of 190 and 1/10 of 91. Now to find 1/10, we can divide by 10. So 190 divided by 10 is 19, because if we're dividing a multiple of 10 by 10, so that's a number with a 0 on the end, we can just take off an end 0. So the length of the model will be 19 centimeters, and then to find the width, we need to divide 91 by 10. Now, if we're dividing a whole number by 10, we can imagine the decimal point on the end, and then to divide by 10, we move the decimal point one place to the left, so that's 9.1. Or we could write the number 91 with the decimal point on the end, copy it down, and then move the digits one place value, so 1 square to the right. So that means the width of the model will be 9.1 centimeters. Kirsty says when you double the size of an acute angle, you always get an obtuse angle. Explain why Kirsty is not correct. So first we can explain what an acute angle is. An acute angle is less than 90 degrees. And now, to show why Kirsty is not correct, we can give an example. So 1 degree is an acute angle, and double 1 degree is 2 degrees, which is still less than 90 degrees, so still an acute angle, not an obtuse angle, because an obtuse angle has to be more than 90 degrees. How many days are there in September, October and November altogether? So for this question, we need to know how many days there are in each month. And to remember, we can use this poem. So 30 days has September, April, June and November. All the rest have 31, except for February. It's the one which only has 28 days clear and 29 in each leap year. So a leap year is every 4 days we get an extra day in February. So that means we have 30 days in September, April, June and November, 28 or 29 in February and 31 in all of our other months. So in September we have 30, October 31 and November we have 30 days. So altogether that's 91 days. The International Space Station orbits the Earth at a height of 250 miles. What is the height of the International Space Station in kilometres? Use 8 kilometres equals 5 miles. So first, let's write down what they've told us is the same. So 8 kilometres equals 5 miles. But we want to know how many kilometres is 250 miles. So we need to think 5 times what is 250. Well, 250 divided by 5 is 50. So that means 5 times 50 is 250. So we want to do the same and multiply 8 by 50, so by the same number. And 8 times 50 is 400, so that means 400 kilometres is the same as 250 miles. Jack buys 1.5 kilograms of potatoes and half a kilogram of carrots. How much change does he get from £5? Well, first of all, we need to know what he spends. So we need to know the total of 1.5 kilograms of potatoes and half a kilogram of carrots. We know that carrots are £1.80 per kilogram. So to find half a kilogram, we need to find half of £1.80 or half of 180 pence. Now 180 divided by 2 is 90. So that means he spends 90 pence on carrots. But he also buys 1.5 kilograms of potatoes. We know that 1 kilogram will be £1.50, but let's find half a kilogram of potatoes. So half of £1.50 or 150 pence. We find half by dividing by 2, and that means 75 pence is half a kilogram. But he buys 1.5 kilograms, so that's £1.50 for the 1 kilogram and 75 pence for the half a kilogram of potatoes, and that gives us £2.25 altogether spent on potatoes. So to find the total of what he spends, we need to add what he spends on potatoes and what he spends on carrots, and £2.25 plus 90 pence is £3.15. But that's how much he spent, and we need to know how much change does he get from £5. So we need to subtract what he spends from £5. So £5 minus £3.15 is £1.85. And to do that, we could either count on from £3.15 to £5, or we could use column subtraction. And when we do that, we get £1.85. So that's how much change he gets from £5. X plus 2y equals 20. X and y are whole numbers less than 10. What could x and y be? So 2y means 2 times y. So we need to think what plus 2 times what equals 20. And of course x and y will be different numbers. So if x was 1, 2 times y or 2y would have to come to 19 because 1 plus 19 is 20. But we can't have half of 19 because that's 9 and a half, and we're told that we need x and y to be whole numbers. So let's imagine if x was 2. 2 plus 18 is 20 and 2 times 9 is 18. So x could be 2 and y could be 9, because if we have 2 plus 2 times 9, that's 2 plus 18, so comes to 20. Or we could have x as 4, and then 4 plus 16 is 20, and 2 times 8 is 16. So we could have 4 and 8. Or we could have 6 and 7. 2 times 7 is 14, and 6 plus 14 is 20. And our other possible answer is 8 and 6. 8 plus 2 times 6 is 8 plus 12, so that's 20. But we couldn't have 10 and 5 because the numbers need to be less than 10. So we've got all our possible answers, so we can use one pair that we have here. Tick the fractions less than 5/8. So first we have 1/2, and it's easier to compare fractions if the denominators are the same. So we can find an equivalent fraction to 1/2 with a denominator of 8. So 1/2 is the same as 4/8, and because that's less than 5/8, we can tick 1/2. Now we have 2/8, so that will also be less than 5/8. And now 3/4, we can find an equivalent fraction with a denominator of 8, and we can see that that's the same as 6/8. But 6/8 is not less than 5/8, so 3/4 is not less than 5/8. Now we have 7/16, so we can find an equivalent fraction to 5/8 with a denominator of 16. 5/8 is the same as 10/16, and 7/16 is less than 10/16, so we can tick this fraction as well. And finally, we have 24/32, so we can find a fraction equivalent to 5/8, which has a denominator of 32, and we can see that that's the same as 20/32. So 24/32 is not less than 20/32, so not less than 5/8. Layla makes jewellery to sell at a school fair. Each bracelet has 53 beads. She makes 68 bracelets. Each necklace has 105 beads. She makes 34 necklaces. How many beads does Layla use altogether? So first we need to find how many beads does she use for the bracelets, then how many beads does she use for the necklaces, and then we can add those totals together. So we know that each bracelet has 53 beads and she makes 68 bracelets. So we need to multiply 68 by 53. Because if we know how many there are in one thing and we know how many things there are, we can find the total number by multiplying, and 68 times 53 is 3,604. And then to find the total number of beads that she uses for the necklaces, we need to multiply 105 by 34, and that gives us 3,570. So now that we know the number of beads she uses for the bracelets and for the necklaces, we can add those together and that gives us the total number of beads. So that's 7,174. Adam is making booklets. Each booklet must have 34 sheets of paper. He has 2 packets of paper. There are 500 sheets of paper in each packet. How many complete booklets can Adam make from 2 packets of paper? So we know that he has 2 packets and there are 500 sheets in each packet. So that's 2 times 500, so 1,000 sheets altogether. And we know that each booklet contains 34 sheets. So because we have 1,000 sheets altogether and 34 in each booklet, we can divide 1,000 by 34. So to do that, we need to work out our 34 times table. And I usually like to stop at 5 times and then look back at the question. So if we take the first 3 digits together, we have 100 divided by 34, and the closest number to 100 that's still less than 100 is 68. So we can write that below, and because it's 2 times, we can have 2 in our answer line. Now we subtract and bring down. So 100 minus 68 is 32, and we can bring down the 0, so we have 320 divided by 34. So after 170, if we add 136, so add 5 times and 4 times, that will give us 9 times. So that's 306 for 9 times. And because that's close to 320, we can write 306 below, and because that's 9 times, we add 5 times and 4 times, we get 9 times, so we can write 9 in our answer line. Now we can subtract, and 320 minus 306 is 14, but we don't have any more digits to bring down. So that means this 14 is the remainder. So 1,000 divided by 34 is 29, remainder 14. So that means he can make 29 complete booklets, but then he'll have 14 sheets of paper left over. We could also solve this problem first by doing the same thing, so working out that we have 1,000 sheets, but then we could count up in steps of 34 until we get to 1,000. So one booklet is 34 sheets. If we multiply by 10, 10 booklets will be 340. And then for 20 booklets, we can add another 340 or multiply 340 by 2. And that tells us that 20 booklets will need 680 sheets. But if we add another 340 to find how many sheets we need for 30 booklets, that will give us 1,020, but we only have 1,000 sheets. So we can find 29 booklets by subtracting 1 booklet, so subtracting 34 sheets from 1,020, and that tells us that for 29 booklets we need 986 sheets. So that's how we know that Adam will make 29 complete booklets, because that's less than 1,000, but to make 30 he would need more than 1,000 sheets. ABDE is a rectangle on coordinate axes. The sides of the rectangle are parallel to the axes. Point C is the centre of the rectangle. What are the coordinates of B and D? So we need to find the coordinates for these points here. So we can write what we know on the axes, and the first coordinate is always the x coordinate. So here we have an x coordinate of 25, because we can see that the first coordinate for point A is 25. And then point C has an x-coordinate of 40. And remember, that's the point in the centre of the rectangle. Now the difference between 25 and 40 is 15. And because C is in the middle of the rectangle, to find the x-coordinate for points B and D, we'll have a difference of 15 on this side as well. And 40 plus 15 is 55. So that means our x-coordinates are both 55, because they're both in line with this point here. And now to find the y-coordinate, we can see that at point A, the y-coordinate is 30, because that's the second number in the coordinates for point A, and point B is in line with point A, so that will have a y-coordinate of 30 as well. Now point C has a y-coordinate, so a second number, of 22, and we need to find the y-coordinate for point D. Now the difference between 22 and 30 is 8, and because C is in the middle or at the centre of the rectangle, we'll have 8 on this side as well. So we can work out the y-coordinate for point D by subtracting 8 from 22, and that gives us a y-coordinate of 14. 6 identical right-angled triangles are arranged to make a rectangle. Calculate the length of the rectangle. So here we can see that the rectangle has a width of 7 centimeters, and that's the same as the height of one of the triangles. So notice this triangle here is the height of a triangle, so this length will be 7 centimeters. But now we need to know what is the length of the base of a triangle. We'll notice here we have 2 bases of a triangle, and that's a total of 7 centimeters. So to find the length of one base, which remember will be the same as this base here because the triangles are identical, we can divide 7 by 2. So that's 3 remainder 1, so we can extend with a point 0, and then 10 divided by 2 is 5. So the base of a triangle will be 3.5 or 3.5 centimeters. So the total length of the rectangle will be 7 centimeters plus 3.5 centimeters, so that's 10.5 centimeters. The distance from point P to point R is 800 meters. The distance from point P to point Q is 4 times the distance from point Q to point R. Olivia says it is 600 meters from point P to point Q. Explain why Olivia is not correct. So the distance from P to Q, so this distance here, is 4 times the distance from Q to R, so 4 times this distance here. So what we can do is mark our diagram to show that we need 1, 2, 3, 4 jumps to get from P to Q, and just 1 jump to get from Q to R. So that's 4 times the distance, 4 times as many jumps to get from P to Q as to get from Q to R. Now what we can do is divide 800 by 5, because 800 is the total length from P to R, and we've split this into 1, 2, 3, 4, 5 equal jumps. And they don't look like equal jumps. It looks like this jump is larger, but I'm imagining that's because the diagram that they've drawn for us is not to scale. So 800 divided by 5 is 160, so that's a difference of 160 with each jump. So to find the distance from P to Q, we can multiply 160 by 4, because we have 4 lots of 160, and that gives us 640. So it's a 160 meters from Q to R, because to get from Q to R, that's just 1 jump, so 1 lot of 160, but it's 640 metres from P to Q, because that's 160 times 4. If it was 600 metres from P to Q, it would be 600 divided by 4, so 150 metres from Q to R, and 600 plus 150 is 750, not 800. So if the distance from P to Q was 600, we would divide by 4 to get the distance between each of our jumps, and that would be 150. But if all of these jumps were 150, that would make 750, and we're told that the distance from point P to R is 800 metres, not 750.